Hello everybody. We are continuing with our standing tree measurements lecture series, and this week we're going to focus on tree height and how do we calculate tree height. So there's going to be two main ways that we would do it in the field. The first one is with a clinometer, and we'll talk about that in great detail. And then the second way is the one that's being demonstrated here, is the use of a laser hypsometer that will do all of the math for us and show us how tall the tree is as long as we point the laser at the right parts of the tree. And so we're going to just kind of, in this lecture, go over the process as close to step by step as we can, and then talk about other calculations that we can make for tree height. So first of all, with tree height, what is it when we're saying tree height? Specifically, what we're saying when we're measuring tree height is the distance from the ground to the highest living point of the tree. That's what we're considering tree height. So from the ground to the highest living point on the tree. Why would we want to measure tree height? I think the biggest part of it in terms of inventory and in terms of numbers is being able to get to volume of the tree, and then really being able to say just exactly how much wood we have out there, because height is directly correlated with volume. But I think even more importantly, it really comes down to being able to match up what we see with our eyes. One of the biggest things when you walk into a forest is right away, if it's full of big, huge trees and very tall trees, that's very noticeable and it sticks out in your mind. And if you're trying to convey how big some of these trees are, or how tall and how straight and how perfect looking some of these trees are, tree height is going to be a very important number to really get them to be able to have what their eyes and what your eyes see match up with the numbers on the page. We do have three main ways to go about this. The first way is by using a height pole, which is just a pole with different marks on it or gradations on it that signify a certain height. And these are used for trees when you don't have a well-developed stem, or younger trees sometimes are bushier to where you can't really get a good look at the stem, and it's just easier with these shorter, younger trees to be taking these measurements using a height pole. Whereas once the tree is of a larger size, where a height pole would be a little too much, it's going to be then focused on the idea of using right triangle geometry or trigonometry, and just being able to calculate tree height using angles and distances. This works out well because we've already gone over how to pace, and so when you're out there cruising and doing inventory, it'll help that if you have a good pace, because one of the things that you have to do with tree height is you have to measure off a distance away from the tree that you're measuring. And so the more accurate way of doing that would be to take your tape and pull it out every single time from every single tree. But that's going to take a lot of time. And once you get comfortable with how far away you should be from a tree, and you note that you have a lot of confidence in your pace, you'll be able to just pace it off and go back from the tree and be able to get to a certain distance. Now, that is what we need to do with a clinometer. What's really nice about using the laser hypsometer now is that you can go back any distance from the tree, and you don't have to worry about how far was that, which direction did I go, any of that. As long as you can see the bottom of the tree and the top of the tree and hit it with the laser will do all of that math for us. So that's a plus. So going over these in detail, in terms of using a height pole, as we can see in the I'll slide myself down a little bit. If we see in these pictures on the right, we've got this yellow height pole, and then you can extend that height pole and be able to measure seedling heights. Usually, you can go up to 40 feet, but it's really difficult to measure anything over 20 to 25 feet. And most of the time when I have used a height pole in the past or taught anybody to use a height pole, we're usually looking at things about 15 feet or less, just because the height pole gets a little bit difficult in trying to use it. But one of the other reasons why we use a height pole, not just the fact that the trees are shorter and we can't get a good view of the stem, but also the idea of that we need really exact measurements. The laser and the clinometer will give us good measurements and accurate measurements, but they are accurate based on trigonometry. Whereas when we actually have the height pole, we actually have our measurement device right there next to the thing that we're measuring. So, and we can get it to calculate down maybe even a little bit further than with the laser or the clinometer. With the laser or the clinometer, more than likely we're getting it down to a whole number, so 100 feet or 60 feet or 55 feet. Whereas maybe if we need to know that it's 5.25 feet or 5.75 feet, that sort of a thing, the height pole would help us out to give us a little bit more accurate number. So to give you an idea of when would you need these more exact measurements. So if you have something like a pine plantation and you're doing research, so you got all these trees, they're supposed to be exactly the same and grow up to be exactly the same way because it's artificial regeneration and you bought the same seedling over and over again, and we want to figure out which ones are maybe different in terms of genetics, or if you want to try and try different fertilizers on that area, or maybe you burn one part of the area but not a part of the other, then you'd be able to kind of see those effects, and it would really make a difference as to if this tree over here is 7 feet tall and this tree over here is 6 feet tall, or this tree over here is 10 feet tall but this tree over here is 4 feet tall. Though you'd want to know all those small differences. So with the trigonometry behind tree height, it's not very complicated trigonometry. It's your basic trigonometry. We're talking about the tangent formula, where we've got opposite over adjacent, and so in this case here we've got our tree height and we've got our distance away from the tree. So if this is us over here, this would be our angle, and to get our tangent of this angle, we would go opposite over adjacent. This is also the same way that you calculate slope, because you get rise over run. And so what we're trying to get is we're trying to figure out this height right here. And so we're going to be able to do that by having this angle right here, and then this distance right here will be able to get us that distance. And the way that we reroute, we work that opposite over adjacent equals the tangent of this angle here is right down here. We make it where it's h equals the tangent of this angle times this distance. And so that's all we're looking to accomplish in measuring tree height in terms of our trigonometry. Now we're going to adjust it slightly to be able to make it work to get the whole tree, and even using slope, where we have to, maybe we're going to be downhill or uphill from the tree to make sure that we're getting the right value. But we're taking this basic formula and figuring it out from there. So move myself up here. All right, so when we're trying to calculate tree height using a hypsometer, the first one we're going to kind of focus on is the idea of the clinometer. Now, what's the only real major difference between the clinometer and the laser is that we still have to do a slight bit of the math using the clinometer, whereas with the laser it's going to do everything for us. So the biggest thing to understand with the clinometer is that it's got different scales on it when you look through it. And so the clinometers that we have are going to have a topographic scale or topo scale or 1/66 scale and a percent scale. And so what we're going to do, or to make our math very easy, is that if we're going to use the topo scale, the 1/66 scale, we're going to stand 66 feet away. If we're going to use the percent scale, which is 0 to 100, because that's what percentages are, then we're going to stand 100 feet away. And so that's kind of the basics of it to really simplify the math for us. And then what we're going to do, if we're this individual here, is our eye level is going to go straight to the tree here. But what we need to do is we're going to have to calculate this angle up here. And we're also going to have to calculate an angle to the bottom of the tree. And we're still going to be using right angle geometry, trigonometry, but we're going to have to do it 2 times. And so we're going to get 2 readings, and we're going to have to add them together to get the total height of our tree. Where should we aim in terms of the bottom of the tree and the top of the tree? The top of the tree, like we said, in terms of what is height, we're going to the highest living part of the tree. And for the base, because we're not going to use the stump, and there's always going to be a stump, you kind of want to aim where you think that the tree would be getting cut. Or if you're unfamiliar with what that would be, or just not quite used to it yet, then aim for about 1 foot off the ground for where you take that base measurement. So the clinometers that we use are Sunto clinometers, and that's pretty industry standard in terms of a clinometer maker. There's also these digital clinometers you may see that some people had. I had them at my previous job, but here we've got clinometers, and like I said, we're going to focus on the ones that we have the percent and the topographic scales. So it's really important in terms of how do I measure a tree. In order to measure it correctly with a clinometer, one of your biggest takeaways is how far back should I go from the tree to measure it correctly. And the easiest way to think about it is you want to be farther back than the tree is tall. So if I think that this tree is going to be 100 feet tall, I want to go back at least 100 feet or a little over 1.5 chains away from the tree. If I think this tree is going to be 50 feet tall, then if I go 1 chain or 66 feet away from the tree, then I'll be plenty far away. But just the idea that you want to be farther away than the tree is tall. If you're looking through the clinometer and you're not sure if you went far enough away or not, if you look up to the top of the tree through the clinometer and you get 60 degrees or more, and if you look to the down to the bottom and you get less than more than 15, probably more than negative 15, depending on what kind of elevation you're at, you're really going to find that you're probably doing this and this, which means you're probably way too close to the tree. You want to be looking out. So if I turn myself to the side, I want to be looking out. I want to look up. I want to look down. But I don't want to be looking all the way up or all the way down, because the farther you go on the scale with the clinometer, the less accuracy that it has. Get myself out of the way again. All right, so step-by-step process if I'm using the topographic scale. So I'm going to measure out 66 feet, or once I get good with it, paste 66 feet or one chain away from the tree. I'm going to hold my clinometer. There's a red dot on it. I'm going to hold it with the side with the red dot away from me. And then I'm going to look through the glass meter. Now, inside of this glass is going to be the scale. But what you're going to do is you're going to actually have one eye looking at your target or your tree and the other eye looking through the clinometer. You're going to point down at the base of the tree and you're going to get that reading. Then you're going to point to the top of the tree and get that reading. You're going to either record those numbers or you're going to just put them into our formula, which if we're using the topographic scale and if we went back 66 feet, all we need to do is all we need to do in terms of math is top minus bottom. So let's just say I go back, I measure out 66 feet, I'm good. I take out my clinometer, I look down, I see 2. I look up and I see 49. 49 minus 2, this is a 47-foot tall tree. And that's it. The one little key thing to remember too, though, is to look and see, because I am looking down sometimes. If it's down below eye level, it's going to be a negative number. And so let's just say I got my same 2 readings, except it was -2 and 49. Then the math is 49 minus -2, which would actually be 51. So it's really important to make sure to look and see, do I have positive numbers or negative numbers? Because if it's because I'm subtracting each time, if I'm subtracting a negative number, then it's a positive and I'm actually adding. So make sure to look at your numbers. So here's just an example there. So here's our trusty forester here. He went back 66 feet away from the tree. He looks at the tree. He gets a -30, which is he's looking really far down, and he gets a +35. So that is 30 minus -30, or sorry, 35 minus -30, which means it'd be 35 plus 30, which would mean it's 65 feet. And over here on the right, this is what you'd actually see when you're looking in the clinometer. You're going to have 2 scales. One of them is going to be the percent scale, and one of them is going to be the topographic scale. If they don't have the percentage symbol or some obvious symbol on every part of it, then either look all the way down or all the way up, and at the end of the scale you should see a percentage symbol or see 1 to 66, something that makes it obvious which side is percent and which side is topographic. So if we're using the percent scale, the big difference is we're going to go out to 100 feet, because remember, with percentages we talk about 0 to 100%. So we're going to stand 100 feet away from the tree, red dot pointing away from us, looking at the tree with one eye, looking in the clinometer with one eye. We're going to point at the base of the tree, we're going to point at the top of the tree, we're going to get our numbers, and then we're going to subtract the bottom from the top. And so here is that example. So here's our forester. They are 100 feet away from the tree. So they look up here and they got 126%. They look down here, they got 16%. And then, but they realize they're downhill specifically in this one. So they also know that when they looked eye level right here, the difference between the base of the tree and their eye level was 16 feet. And so what they did this time was they said, all right, so what this is 126 feet, but because 16 feet of it is the fact that of where I'm at, then the tree is actually only 110 feet tall. So it's really important to understand that these are simple math calculations, but there's all sorts of different variables in terms of, am I standing straight across from the tree? Am I downhill from the tree? Am I uphill from the tree? In this case, if this tree is 110 feet tall, is he back far enough? So we talked about these big, huge numbers like this, right? Is he back far enough, or did he need to go back farther to make sure that he got a really accurate measurement in terms of this tree? Because in my mind, he probably should have gone back a little bit farther. Also, then let's add in a little bit of artistry here to the tree height. If I'm talking about this tree right here, and we're going to come and harvest this tree, we've got a little bit of that butt swell we talked about with the DBH, some taper. So we probably would be cutting this tree a little bit higher. So I'm thinking my base of the tree would actually probably be more like up here than it is down here. So there's all sorts of little variables. There's all sorts of different ways to do it to make it perfect. But it does still come down to the basics of look through this clinometer, look at the bottom of the tree, look at the top of the tree, top minus bottom reading. And here is that formula, but let me add in a little bit more, which is the idea that you don't technically have to go back to these specific distances. We do go back to these distances because they're easy in terms of the math. But the actual formula for either one of them is that your height is your top minus your bottom times your actual distance over your index distance. Now, the reason we can just do top minus bottom is because if you have your actual distance and your index distance being the same thing, then you've got top minus bottom times 1, which is just going to be top minus bottom. And so for the percent, if our index distance is 100 feet and we go back 100 feet, then it's just top minus bottom. For the topo scale, our index distance is 66 feet because it's 1 over 66. So if we are back 66 feet, then it's just top minus bottom. But we can do any distance. So for instance, here in this example, this person went back 50 feet. Now, so they got a reading of 124%, and so we're using percent. So now we know our index distance is 100 feet. So they went back 124%. Or sorry, they saw up there that angle is 124%. They saw this as negative 16%, right? So if I subtract top minus bottom, which means I'm going to add 16 to 124, I get 140. But it's 140 times the actual distance, which is 50, over the index distance, which is 100, or 140 times 0.5, which would mean I've got to cut it in half, which means it's 70 feet tall. And so 62 of that feet was in this top angle and 8 of that feet was in this bottom angle. But then if we were in class and you told me this, and I would say, okay, great. But if this tree is 70 feet tall, how far back are you supposed to go if you're trying to measure it correctly? So we'd probably want to be farther back than 50 feet. But the idea is we could do it at any measurement. So we would want to be back probably at least 75 feet or maybe 100 feet to really get a good measurement of this tree height. But we can go back any distance. It's just that the math is much simpler to do top minus bottom if we have our actual distance that we're away from the tree and our index distance being the same exact thing. So if that was confusing in any way to you or just didn't make sense, here is the whole thing summarized in terms of measuring height with a clinometer. Here is my tree. I'm going to look to the bottom. I'm going to look to the top. I've got my specific distance that I went back from the tree. here's what it looks like to look through the clinometer. You have your crosshair here, and then you're looking with one eye at the tree, the other eye looking into this scale and reading off whichever side we've decided to use, and that's going to give us our tree height. Now, because the formula is the same for calculating slope, you can measure slope using a clinometer as well. And so with this example right here, this person walked 66 feet, but is 66 feet the actual distance that they walked? That's what they think, because they paced it off and they did 66 feet, but it was walking up a 40% slope. So if we do our same calculations and put in that same math, what we're actually going to find out is that it was actually 71.3 feet that this person walked, because it was our 66 feet was our horizontal distance, but it actually turns out it's 71.3 feet because of the 40-foot slope. But we can get those same numbers just doing the same formula for tree height. Now, let me move myself out of the way here. Now, the slope correction factor. So if we're on a incline or a decline, we do want to adjust for slope in terms of our height measurement. And so in this case, in this example here, the slope is 43%. So you can either figure that out with your clinometer, or what we'll do to make it easy is we'll just provide a slope correction factor table for you. So they get their slope correction factor of 1.09. So this person, they're only 38.2 feet away, and we're going to assume that they could only get that far away because there's other trees in the way, or it was too hard to see the top and the bottom of the tree. But we would know we'd want them to go back farther if they could, but you know, you got to do what you got to do. So if we look at their measurements, so they got 41% up to the top, negative 54% down to the bottom. And so you add those up because you're subtracting top minus bottom, and minus gives us a plus, and so you get 95. And so your horizontal distance calculation, we have to adjust for our slope factor. So we had 38.2 feet. We divide that by 1.09, so our horizontal distance is actually 35.05 feet. So now if I put that into the formula, so top minus bottom, which we got 95, but then that's times actual distance, which after our slope correction is 35.05 feet, divided by 100, because we're using the percent scale, because we see that it says percentage right there. So that would give us that this tree here is 33.3 feet tall. So this person went back far enough to give us an accurate measurement, even though they've got to deal with slope and all these other factors. Slope correction factor in certain areas is not very important, but out here in California, especially if we head into the mountains, especially if we're working in Northern California, is going to become pretty important, because we're going to be dealing with some pretty decent topography. So the laser hypsometer. So the nice thing about it is with the clinometer, we had to think about, okay, well, I got to do top minus bottom, and I got to make sure that I'm a certain distance away from the tree. With the laser hypsometer, everything is happening inside of that little apparatus. And so what we're going to do with our hypsometer, we're going to pace off a distance away from the object, just so we know that we're hopefully farther back than it is tall. And we need to shoot the laser to get a horizontal distance. And then depending on what mode you are, either some of them usually have a two-shot mode, where basically you get the horizontal distance and you get the top distance, or the ones that I like, or the mode that I like to use, which is more like the clinometer, is I get a horizontal distance, I shoot the bottom of the tree, or in this case a utility pole. I shoot the top of the tree, or in this case a utility pole, and then I get a height measurement. And so what that looks like is that the laser will usually show you all the different measurements and how the calculations were done. And so you can see right here, there's this on the graphic on the left is showing the different modes that you have, because the other thing is you can also use this just to do distance, and that'll actually come in handy when doing inventory and cruising. There's other uses for figuring out straight line distance, and we'll talk about that later. But in terms of our height, so you've got your height mode, which is down here at number 3, and we can see it shows us all that we got our horizontal distance, our distance to the top of the tree, and then it gives us our height of the tree. We've got a distance mode, we got a horizontal distance mode, and we got an angle mode. So there's lots of different things that this little apparatus can tell us. Angle mode is if we were looking for slope, that'd be useful for us, but the laser does all the math for us, takes out a little bit of the guesswork, and allows us to just move quicker in terms of doing our inventories. So I'm going to slide myself down here to the right. So what kind of issues or what things might you run into that you're not quite sure about when measuring height? And one of the things that'll be interesting is the idea of the growth form of the tree, and specifically X current growth form versus D current growth form. And so we've got a couple good examples here. So an X current tree where you got a single strong dominant leader. So remember with our definition of tree height, that is from the ground to the tallest living point on the tree. So with an X current form, it's very obvious, and I like to think of it to try and make sure I don't confuse X current and D current. The idea of X marks the spot, right? It's very obvious on an X current tree where you should be shooting, whereas a D current tree, it may not be as obvious. Like, do I shoot right here or right here or right there? And it becomes a little bit harder because you got multiple co-dominant and competing leaders and branches. And what I like to do in my mind is almost take this example of a plantation tree here and kind of try and apply that to the decurrent tree. If the main stem just kept going up and up and up and up, which part of this tree would be that main stem? And that's where I look at shooting the top of a decurrent tree. So it's a little bit more difficult. It is a little bit of artistry. Not everybody's going to do it the same way. Not everybody's going to see it the same way. Whereas something like this is going to be very obvious where we all should be aiming. But this, if you're right here or you're right here, your values aren't going to be that different, hopefully. But you want to get as accurate and precise as you can. And really, it's with these decurrent trees, it's really much more about precision and the idea of being able to have some sort of a way of doing this where you do the same thing over and over again. So here's just a couple picture examples to get an idea. When we look at this X current growth form here on the left, really easy to say, all right, I'm going to shoot at the base right there, and then my top that I'm going to shoot is right there where that branch would end. Now, the other thing to think about is if you're close enough to see the difference, and with a lot of trees out west will be so far away you won't be able to really see this difference. But if you have really long needles that are sticking up and way above the actual branch of the tree, I prefer myself to shoot where the leader, where that branch or the stem ends as the top of my tree, as opposed to where the needles end. But with a lot of the trees out here, you're going to be so far away, you're not going to be able to actually see that difference. Whereas on the right here with this oak and its decurrent growth form, in my mind, I'm going to kind of take this main stem here and try and go straight up from it and see what point I can see where the branches end, and I'm going to call that my tree height. Crown measurements, so the length and width of the crown are going to become very important also with decurrent trees. What about trees that aren't straight or have a little bit of a lean to them? So here's a couple good examples here of a tree that's decently straight with a little bit of a decurrent growth form. I'm going to kind of take that main leader up, find a good spot in this little red dot. That's probably where I'll shoot tree height. Whereas this one, I've got this lean to it. Well, I want to kind of go with the lean, just like in DBH. Measuring the DBH, I want to go with the lean, and I kind of want to just kind of still go straight up that leader as much as I can and find like a good spot. Or I want to go see which way it's leaning to, and I want to go straight up and just make a straight line until I get to the top. Whatever way you think gives you the most accurate measurement of that actual tree height. It's going to be a little bit of artistry. It's going to be a little bit of it depends. But the big thing is to come up with a consistent process so that we can at least limit the bias in our precision, and then we can continue to work on our accuracy. So total height versus merchantable height. Now, with the measurements that we do in this class, we're going to focus on total height because merchantable height is, there's so much more artistry in it, and so much more kind of a range of acceptable answers, whereas it's a lot easier to come up with total height. So if I'm looking at this graphic right here, we shoot the same for the bottom. But then for total tree height, I know I'm going up to the tallest living part of that tree. But a merchantable height, what I'm doing is I'm basically saying, depending on what kind of products I want to get out of this tree, I'm going to aim at a different part of this tree because I know that I can use more or less of the tree depending on the product. So if I want saw timber out of this tree, I'm gonna have to get bigger pieces of wood or bigger logs out of it. So I can only go up to maybe here to get saw timber. But if it's a pulpwood tree, which I'm gonna chip up this tree and turn it and grind it down until it becomes paper and all of that, maybe I can go to way up here. And so it's usually, you'll hear something like to a 6-inch top or to a 4-inch top or to a 3-inch top, and that is your merch top, and that's where you're supposed to be aiming towards. But it's very difficult to kind of master that skill, so it takes a lot of time and effort, whereas total tree height's a little more obvious. And so when we're looking at total height, like we said, we're thinking from the ground all the way to the top. That's our version of tree height. And when we're saying total height, we're just thinking, where is the logging crew going to come in and cut this thing off the stump, because we don't really want to know how tall the stump is, all the way to the tallest living part of the tree. And that's our total height. Also, because we're going to talk about live crown ratio in a little bit, the length of the crown length, or the crown height, or the height height of the live crown, all sorts of different terminology you might hear, but all it means is, what is this from the top of where I have crown to the bottom of where I have crown. But we want live crown. So if I had just some empty branches down here without leaves on them, I don't want to count those. I only want to count branches with leaves on it as the crown. So with merchantable height, we're really focused on the usable portion of the stem. So it's So with merchantable height, we're measuring from stump height to an upper stem diameter. So we've already talked about the idea of diameter and how we measure it at breast height. But what we're talking about when we're measuring tree height for merchantable height is you're going to go from the stump height to where this tree tapers to where it's only 8 inches wide or 6 inches wide or something in that general vicinity for saw timber. And then for pulpwood, maybe I'm going to a 4-inch top or a 3-inch top or a 2-inch top or a 1-inch top, wherever this thing tapers down to 4 inches or 3 inches. It depends on what products we're looking for. It depends on how much wood we have. It depends on which markets are doing better. It depends on what kind of tree it is. It depends on all sorts of different things. It depends on how good the trees are. Are they straight? Are they crooked? And the wood isn't that sound. All those things will change in terms of merchantable height. That's why we're going to definitely focus on total height. Merchantable height can be measured in feet, just like we've done with the total height, but it can also be measured in logs. So a log is equal to 16 feet, and so you can measure it in logs or half logs. So if I move myself out of the way here up to the top, you can see my example here that says if you measured this tree to be 52 feet right here, 52 feet tall to this 8-inch top, you could record that as 52 feet, or you could say that it's a 3-log tree, because 52 feet actually comes out to be 3.25 logs, and we're just rounding down. So you could round that up and say it's 3.5, or you can round it down. It just depends on what your company says to do, or just whatever consistent pattern that you have come up with to prevent bias in your numbers. So for me, I round it down just to make sure that I'm not overestimating. And so if I measured out 52 feet on the clinometer, I would say it's a 3-log tree. Now, when you get better and you're cruising and you're doing much more estimating in your cruising, you're going to be able to just start estimating tree heights and looking and just say, okay, there's the bottom, there's the top, 1, 2, it's about a 3-log tree. There's your tree height. So that's why merchantable height really becomes much more of an art form, and it's pretty impressive when you see people who are very good at figuring it out. So I brought in this graphic right here on the left to really just give you this idea that merchantable height can vary and can vary a bunch. So if you have these branches and injuries here and smaller injuries here, are you going to say that the usable portion of the stem is from the stump height to these branches right here? Or because of this injury, are we going to cut it off here? Or because of this injury, are we just going to say it's from here to here? Maybe we want to go all the way to where the main part of the crown is. So maybe the usable portion of the stem is from here to here. It really depends on what we're going off of. Are we specifically going, are we just saying take it to the live crown? Are we saying take it to an 8-inch top, 6-inch top? It can vary quite a bit. So just providing you a graphic here to just kind of put that whole thing together. So we've got our stump height, we've got our total tree height, we got our stump height here. This is our horizontal distance. We might have some sort of a merchantable height. We have our total height, and we have the height of our crown right there. So those are all the different height measurements we might get. So when should you use total height or merchantable height? So total height typically used when measuring trees during stand development to quantify growth or calculate, or to be used in calculations for site index, which is something we'll talk about in this class. But basically, it's a chart where you get your height and you get your age, and you'll be able to see where this tree falls in terms of, is it a big tree, is it a small tree, based on other trees that have grown in that area. You get similar charts if you have a baby. You'll get height and weight charts, and they'll tell you, your baby's in the 90th percentile for height and 66th percentile for weight, and those are the same thing as these site index charts. We're basically looking at the tree and saying, this tree it's either a big tree or a small tree, and this is why. Whereas your merchantable height is used much more and used specifically in inventory when you're trying to quantify the usual portion of the stem. So when you're much more interested in logs and the type of product was the word I was looking for. The type of product that you're interested in terms of the tree that you're cutting down. So then other height measurements, we're going to focus on one other one. And really we've talked about it already, and that's the idea of this crown length or height of the crown, however you want to say it. Because we want to calculate something called live crown ratio, which basically helps us to know how healthy our trees are. Because we know that if trees have a lot of needles and they're kind of bushy and healthy, we know that the tree's doing well. Whereas if the tree has a small crown, it doesn't have a lot of needles, that tree is going to be unhealthy because it can't do a lot of photosynthesis, which means it can't get a lot of energy, which means it's not going to be as productive. So we want to make sure our trees have the right size crown. So we want to make sure that we know how to calculate our crown length, which would be the same way that we would calculate our tree height, except our tree height, we're going to look to the bottom of the tree and to the top of the tree. Well, to get our crown height, we look at the bottom of the crown and we look at the top of the crown. Now, because we want to get the live part of the crown, that's where we get a little bit of artistry again. Is this the bottom part of the live crown? Is this the bottom part of the live crown? Because there's a little bit right there. That is going to be an it depends type question, and it's up to you to figure out, but that's how we do forestry. You just have to come up with some sort of a pattern that makes sense to you so that you do it the same every time to prevent bias. Now we're going to take that measurement and put it in to a simple ratio, which is just take our live crown length, put it over our total tree height. So in this example here, 15 feet divided by 50 times 100, so 30%. So what we're saying is that 30% of our tree is covered with live crown. And then we're going to figure out, does that mean that's a good amount of crown? Is it not a good amount of crown? And we'll talk more about that in other classes. In terms of our measurements, that's how you get it measured. But live crown ratio is going to become really important in other classes like silviculture, where you take that measurement and start applying it and looking at the stand as a whole, or the tree with the trees next to it, and really tell, is this tree healthy or does it need some work?